How do you define an ellipse? Alright, there it is. Done. Just joking. Okay. Okay, here's an ellipse. Draw a fancy circle that's a little flattened out, aka oval. That is an ellipse. Okay, so how do we define it? Well, now this is not a very good academic explanation of what an ellipse is. I'm just really, the purpose of this video / lesson is to just show you guys what the ellipse equation looks like in standard form, and like how to make sense of all its variables. It's very similar to the circle equation. So we're going to start out with the x minus h, square it, and we're going to add a y minus k and square it. The h and the k, that's still the center. So that's the center of your shape, your ellipse. Okay, that's a big dot right there. Okay, and then it's equals 1. It doesn't equal r squared. It equals 1. And then on the left side, we're going to have these fractions. And this is where those denominators come from. There's something that goes straight across the ellipse, and that's called the major axis. Now, in terms of the equation right here, we don't care about the whole major axis. We only care about the distance from the center to one of the sides. And when it reaches the side, that's where you find your vertex. So your vertex is right there. And the distance equals A. So, if I were to ask you guys, what is the length of the major axis? Why does it say axis? Alright, I'm just going to erase that. Okay. What is the length of the major axis? There's one A right here. What do you suppose this length is going to be?
2A.
Yeah, that's also going to be A. So the length of the major axis is 2A. Now in our equation, you're going to write A squared, because it has to do with the Pythagorean theorem, that length right there. And we're going to talk more about that later. Like I said, this is not a good academic explanation of an ellipse. Okay, then the other side, the other way, this is called, well, all the way across, is called a minor axis. So, minor axis. And this one goes to the covertice. So call it the covertex. On the other side, it also goes to a covertex. Oh, and I forgot the vertex for the other side of the major axis. Okay. Now for the length of the minor axis right here, we're going to call that B. So what's the length of the whole minor axis? Yeah, it's B. No, not B squared. It's 2B. But when it goes into our equation, it goes B squared, because it has to do with the Pythagorean theorem. This is the standard form of an ellipse. Now you guys are going to be working with ellipses that are centered at the origin. So that means if it's centered at the origin, the h and the k are 0. So you're not going to have an h and a k. You're just going to have x squared and y squared. Okay, the last thing, which I forgot to tell period 1 and 2, is the focus, the foci. The foci go right here on the major axis. Foci! Okay, the foci has a distance from the center known as C. Now, why do we need to know what C is? Because A, B, and C are all related by saying A squared minus B squared equals C squared. This equation is important. This helps you, like if you're missing a B, you just plug the C and the A into this, and then you can find the B. If you're missing a C, you can plug the A and the B into it, and you'll find the C. Okay, and this is also important. The A term is always connected to the major axis, and the B is always connected to the minor axis. Foci is plural. Foci is plural for focuses. This is a focus. Focus point. But if you're talking about both of them, then you're going to say, these are foci. Some people say foci, but no, it's foci. Foci sounds way cooler. Sounds like you're going to chop someone's head off or something. Foci! You're like, oh no, my head. Okay, here's the next one. Now, I'm going to change it up a little. I'm going to put my ellipse vertical. The other one, this one right here was horizontal. And for the horizontal one, the a squared was underneath which variable, the x or the y?
The X.
The x. Okay, now we have a vertical one. So the question here is, where's the a squared under? Well, let's put our center right here. We're going to write an equation for this one. I'm going to give you the length of half of the major axis. We're going to say that this is 5. And half of the minor axis, we're going to say this is 2. So how would we write an equation for this? Well, we start off with x minus h, and we're squaring it. Wait, what is h? Oh, h is going to be, let's see, the center is going to be 0, 0. And so what is h going to be?
0.
Yeah, h is going to be 0. So we put that over something, and then we have y minus 0, because the k is 0, square it, and that equals 1. Alright, now, because this is vertical, that changes something in our equation. What is 5? Is 5 the a, or is 5 the b? 5 is the a, because it's part of the major axis. It's half of the major axis. So does 5 squared go underneath the x, or does it go underneath the y? I mean, this is the first time I'm ever talking to you guys about this, and I want you to take an educated guess. The major axis is vertical. So, is 25 going to go underneath the x or the y? Which axis is vertical? The x-axis or the y-axis? The y-axis. And so the 25 goes underneath the y. So what number goes underneath the x? 4. Why is it 4? I see a 2. Because it's 2 squared. Now if I simplify it, it's going to look like this. X squared over 4 plus y squared over 25. That equals 1. That's your equation of this. What's that? No, there's a little bit more. Now if you wanted to find the foci point, the focus points, you have to know how much to count from the center on your major axis. So we need to know what c is. And so we're going to go a squared minus b squared equals c squared. Do we know what the a is? Do we know what the a is?
No.
Yes, we do. It's 5. I didn't even point at it. 5. Okay, so we got 25 right here. Do we know what b squared is?
4.
Yeah, it's 4. So we take the 4 and we subtract it. That equals c squared. So we have 21 equals c squared. So what does c equal? C equals radical 21. Okay? So that means our focus point is going to be radical 21 spaces from the center. And then it's going to go the other way also. So we have radical 21. There's your 2 focus points. This is a focus point, and this is a focus point. C gives you the distance from the center to the focus point. From the center to the focus point. There's always 2 focus points in an ellipse. So there's really 2 problems here. One problem I solved by finding the equation of the ellipse, and the other problem I solved, which was find the focus point, I solved by finding what c, the value of c is. Okay, now there's one more problem that only takes 30 seconds to answer. We have to write this equation of the ellipse in standard form. Now this is what you think of when you think of standard form. What is this supposed to equal? What is it supposed to equal right here? That's supposed to equal 1. So how am I going to make 24 into a 1? Divide by 24. And if you divide that side by 24, you have to divide this whole side by 24 also. When you divide the whole side by 24, you make sure you divide each term by 24. And then you simplify it. And so this is 1 right here. And when I simplify this one, what's 6 over 24 simplified to? 1 y squared over 4. And we don't need the 1. So we just write it like that. And then plus, and what's 3x squared over 24 going to simplify to? Yeah, x squared over 8. There's a 1 right there, but we don't need to write that 1. So this is the equation for the standard form equation for this ellipse.
What would that be?